All right, hello, just a little video to help you out with the skeleton lab, which compares and contrasts how male and female skeletons differ. So I'll read through it for you here. A skeleton is found. A doctor reports to the police that it's an adult male skeleton. How could the doctor determine if the skeleton were from a male or female? Well, there's several differences that exist between the skeleton of a male and that of a female. The main difference is the shape of the pelvis. The female has a wider pelvis, obviously, to let the baby out. The birth canal. So let's see how some of the measurements compare. We're going to measure diagrams of male and female pelvis, determine how they differ, and use your data to determine if a third pelvis, an unknown one, is male or female. Here are the following keywords you're going to need. If you want to just leaving it here for a couple minutes, you could always pause it to fill these in. The definition of the femur. I talked about the femur also. That's femur for a cow. Longest bone in the body, pelvis, sacrum, and definition of skeleton. So you could pause that, fill those in. You're going to need a metric ruler. We are measuring this in millimeters, which this is the metric side right here. Millimeters are the little lines. So where that number 1 is, that's a centimeter. So actually where that number 1 would be 10 millimeters. 2 centimeters would be 20 millimeters, and so on. Numbers in between, 21, 22, 23, 24, 25, it's a little bit longer, all the way up to 30, and so on. We're going to measure the following dashed lines in the pelvis. So you're going to compare and contrast the pelvis width, A, the sacrum length, B, the sacrum width, which is C, and the pelvis opening, which is D. You're going to do these same things for the second. Actually, I think I read through that so quickly, but this first one is a male, and the second diagram is a female. So you're going to measure those same A, B, C, D, and put them in the data table on the next page, right here. Now, you will need a ruler to measure these as well. Like I said, in millimeters. And since these are all in millimeters, we should also be labeling all of these millimeters. Unless you want to put millimeters next to every single number that you write, if you put it up in the top of the column, I'll know everything underneath is in millimeters. The next thing you're going to have to look at, the procedure says, is the bottom shape. So the bottom shape of the pelvis, this is the bottom shape. This is the bottom shape right here. This is the bottom shape of this female right here. So you have to tell me if it's either pointed or rounded. So that's what you'll have to write in, where it says bottom shape. It's either pointed or rounded. The next two measurements you have to make are line F and G. Those are both also going to be in millimeters. Line F and line G. Now the procedure says, again in millimeters, the procedure says that if F and G are the same length, then those femurs are straight. If F and G are different, then they are slanted inward. So those are your choices for those columns. The last column is the unknown column. You will need to do all of these measurements. And then finally, you'll have to determine if that's a male or a female. For the questions on the next page, a lot of these you can just write greater than or less than. For example, the pelvis width, male, female. Which one is bigger? So either write greater than or less than. Most of these can be answered in that way. The last page of the lab has some questions that the questions ask about looking at figure 4, which is the graph on the bottom. You don't have to do this graph, it's done for you, but you will have to plot points and see how big or how old a skeleton is based on its femur length. I'll do the first one for you. For example, if it's 200 millimeters, I'll look on the graph where 200 millimeters is. That point right there, if I go down, it looks like I am just before 6 years old. So not quite 6 years old. I just scroll down here. Just before 6 years old. So I could write that as my answer. The first one, let's say about 5.5. About 5.5 years old. Do the rest of those questions, and that's pretty much it for that lab. Any questions for me? Don't hesitate to shoot me out an email. Thanks and good luck.